So if you're out there right now navigating the choppy reality of modern cloud architecture, I mean, whether you're prepping for a big technical meeting or just trying to get that aha moment that, cuts through all the noise, the challenge is real. The whole infrastructure landscape is just more fragmented, more distributed, and frankly, more complex than it has ever been. Today, we're doing a deep dive into the foundational purpose of the tool that really sits at the center of all this complexity, Terraform. And we're not just going to define it. We are zeroing in on the absolute critical insights distilled from a pretty comprehensive stack of source material about why it stands out. Our mission is to give you that strategic understanding of why Terraform matters so much, especially in a multi-cloud world. Okay, let's unpack this.
I think it's really necessary to set the stage here by just acknowledging the pain that IAC, or infrastructure as code, is meant to solve. Just, imagine trying to manually update configs for, say, 50 different virtual private clouds, 50 load balancers,
Oh, wow.
and maybe 100 security groups across 2 totally different cloud consoles. At the same time, that whole effort isn't just slow. It's basically an operational guarantee that you're going to get configuration drift, security holes.
And human error. It's a guarantee of a late-night pager alert is what it is.
Precisely. IAC forces all of that into repeatable, versioned configurations that are written as code. And Terraform's core purpose fits right in here. It's all about managing infrastructure safely, predictably, and, efficiently. But if all IAC tools sort of do that, what's Terraform's unique value? Where does it shine? It's that moment your organization decides it needs to manage infrastructure across multiple, completely distinct vendors all at once. That shift, that's the spotlight moment for Terraform.
And that leads us right to the first key insight from our sources, multi-cloud deployment. So why is this specific choice using, Cloud A, Cloud B, Cloud C? Why is that such a defining use case for this one tool?
Because it's really the peak of modern complexity. Multi-cloud is a strategy where you're using services from 2 or more public cloud providers. AWS, Azure, Google Cloud, Oracle. Maybe for resilience, maybe for geographic reach,
Or just because different teams like different things.
Exactly.
Yeah.
But that convenience, it comes with this massive, massive complexity. See, every one of those cloud vendors has its own proprietary APIs, its own unique configuration languages.
Right, like CloudFormation in AWS, ARM templates in Azure.
Exactly. And they have their own command line tools, too. So if you commit to using the native tools for each one, you are forcing your operations team to master 3 different tool sets.
3 different syntax standards.
And manage 3 completely separate code repositories just to describe what is, in the end, one single application portfolio.
So the operational cost scales exponentially. It's not just double the work. It's a whole cognitive shift every time someone switches context, which has to slow down deployment and make any cross-cloud work really risky.
That is the key fragmentation problem. And the foundational purpose of Terraform is to just eliminate it. It acts as this unifying abstraction layer. It basically says, I don't care if you're deploying a virtual machine in Azure or an EC2 instance in AWS.
We're going to use the same language.
We will use the same language and the same workflow. And this allows all that distributed infrastructure to be deployed across these completely different environments using a single workflow and one shared configuration language.
That consolidation is the answer to the fragmentation pain point. Okay, so let's go from the why the multi-cloud need to the how. Because to make that work, the sources kept emphasizing Terraform's provider-agnostic benefits. Here's where it gets really interesting. Because we need to understand what being truly provider-agnostic actually means. It's more than just having a lot of API integrations.
It is. It's about a fundamental architectural neutrality. The core engine of Terraform itself is designed to be agnostic. It operates with this core assumption that every piece of infrastructure, I don't care if it's an AWS S3 bucket, an Azure virtual network, or even, an on-prem Kubernetes cluster, is just a resource.
A resource with attributes.
A resource with attributes. That's it. It doesn't inherently favor any one cloud system or its terminology.
Okay, so how does that work mechanically? How does Terraform pull off that abstraction without losing the unique power of each cloud?
It uses 2 critical mechanisms. First is the configuration language, HCL, or HashiCorp configuration language. HCL is standardized, it's declarative, and it stays the same no matter the provider. It's also, frankly, a lot more human-readable than some of the verbose JSON or YAML you see in native tools. You just describe the end state you want in these clear blocks of HCL code, and Terraform figures out all the vendor-specific steps to make it happen.
So the mental load shifts. It goes from managing all this different provider syntax to just defining the resource attributes you need. That must lower the bar significantly for anyone who has to pivot between environments.
Absolutely. And the second mechanism, which is maybe the most critical one for enabling this consistency, is the use of the state file. This is often what elevates Terraform from just a deployment tool into a true infrastructure manager.
Okay, walk us through the state file for our listener who's trying to get fully informed on this. Why is that state file such a core concept in Terraform's workflow, especially for managing multiple clouds?
The state file is it's essentially Terraform's memory. It's a record of the current real-world state of the infrastructure it last deployed. And why is this so critical? Because when you run Terraform plan, the tool doesn't just look at your HCL code. It compares your desired HCL code against the current reality that's recorded in that state file. And only then does it figure out the minimum set of changes, the plan, to safely get from point A to point B. This is absolutely crucial for consistency. If you have resources spread across 3 different cloud vendors, that single state file makes sure that when you make a change, Terraform treats all of those resources as part of one cohesive environment. It prevents configuration drift, where manual changes break the automation, because Terraform always knows what it manages, no matter which cloud is actually holding the asset.
Which makes the whole process safe and predictable. It connects the language HCL to operational safety across that fragmented landscape. That level of abstraction has to be the real market differentiator. If another IAC tool is too tied to one cloud, it might be great at managing native resources, but it becomes a huge headache the second you add another vendor because it just doesn't have that unifying state and consistent language. But I have to ask the critical question. If Terraform is this, beautiful vendor-neutral layer, are we giving something up? Aren't we sacrificing access to the newest, most cutting-edge features that AWS or Azure might release tomorrow? Is there a trade-off for this abstraction?
That is the essential trade-off, and it's why understanding the strategic context here is so important. Yes, there is often a slight lag. When a cloud vendor releases a brand new service, let's say a specialized AI chip managed through a new API, the Terraform provider community needs a little time.
To build plug-in code for it.
Exactly, to build and test the plugin to manage that new resource using the standard HCL and workflow. However, for the vast majority of core infrastructure, your VPCs, subnets, load balancers, virtual machines, that lag is minimal. And the strategic benefit of having consistent operations across 3 clouds far outweighs the temporary inability to use some niche, cutting-edge feature in just one of them. Portability and consistency trump feature exclusivity when you're talking about foundational architecture.
Okay, let's connect all these threads for you. We've established that multi-cloud deployment is the organizational goal driven by resilience, cost, you name it, and provider agnosticism, which is enabled by HCL in the state file, is the critical mechanism Terraform uses to achieve that goal, smoothly and safely.
Right, and the so what here is massive for efficiency and strategic alignment. Think about governance and auditing. In a traditional fragmented environment, auditing means tracking separate CloudFormation templates, reviewing ARM.json files, analyzing Google Deployment Manager configs.
That's 3 different syntax reviews, 3 different code bases to track for compliance. It just sounds like a nightmare.
It introduces huge overhead and risk every time a regulation changes. But with Terraform, that entire audit process centers on one unified HCL code repository and one coherent state file that describes your whole infrastructure across all vendors. This dramatically simplifies governance. It improves consistency. It speeds up compliance reviews. You gain knowledge so much faster because you only have to learn one set of core concepts that applies everywhere.
You're not just learning a cloud tool.
You're learning infrastructure as code, as a universal principle. Ultimately, Terraform's defining strength is strategic. It's the ability to avoid vendor lock-in while at the same time simplifying management across these diverse, complex environments. That consistency, that portability, it's all rooted in its provider-agnostic architecture. And that is the core reason it's positioned as an industry standard for IAC today.
So what does this all mean? Our deep dive really reveals 2 central interlocking takeaways about Terraform's core purpose. And these define modern IAC strategy. First, its strategic value is just intrinsically tied to managing the fragmentation and complexity that's inherent in multi-cloud deployment.
And second, it meets that challenge head-on through its provider-agnostic architecture. It offers a consistent language, HCL, and a safety mechanism, the state file, that guarantees predictability no matter who the underlying vendor is. That architectural decision is the critical enabler.
Mastering these 2 concepts, the goal of multi-cloud and the mechanism of provider agnosticism, That's the shortcut to being truly well-informed about the strategic landscape of IAC. It moves you beyond knowing what Terraform does to understanding the strategic why behind its dominance in the industry.
And that leads us to a final, provocative thought for you to consider. If a truly provider-agnostic tool like Terraform becomes the universal, non-negotiable standard for deploying and managing core infrastructure everywhere, what happens to the competition between the cloud vendors? Does it shift entirely away from offering unique tooling and configuration systems? Does the entire focus then shift purely to underlying price, raw performance, and maybe those highly specific, specialized services that are too niche to be easily abstracted away? Think about what that kind of standardization means for the future economics of the cloud wars.
An excellent thought to ponder as you plan your next infrastructure moves. That is all for this deep dive.